So I do have a lot of slides, and some of this is going to trust on what Jessica Bavea had spoken to earlier in the week. One of the key things that I want everybody to understand is that ultimately the human is responsible for understanding these algorithms. You never get to say it was the AI's fault, ever. Everything that you do with these algorithms is a reflection of you and your integrity and your scientific credibility. So the first thing is, and this will be a slightly different perspective from Jessica's, but it's basically understanding large language models. And so this is just a brief background. It started out with neural networks. They've been around for actually quite a while. Then there were recurrent neural networks for sequential data, and then long short-term memory networks. And so vanishing gradients just mean that you wouldn't have convergence, right? And so the transformer revolution was this amazing paper, attention is all you need. And it came out actually from Google. The interesting thing is that Google didn't actually capitalize on that. It was other people and other companies that did. And so once that came out and the understanding of how to use mathematics to get these algorithms to be able to, quote, pay attention to what mattered as opposed to the things that were not as relevant, right? That's what gave us and allowed for large language models to be what they are today. And this is a wonderful slide. It shows, baby GPT-1, GPT-2. And so I found them in late 2020 when OpenAI put up a web interface because, I'm an experimental physical chemist and I'm not a coder. And so before that, it was people on command line and using APIs and things. So computer scientists may have known about these things, but it wasn't really available to the general public. And I became just mesmerized, more than 2.5 years ago. And so I completely pivoted because I saw the possibilities. And I think I've been very lucky. So this is, how does this work, right? You are typing something in or you're speaking. The text is what's called tokenized. Basically, it's just cut up into little pieces. And you can think of tokens as either a piece of a word or sort of comparable to a small word. And those tokens are turned into mathematical vectors. So fundamentally, the mathematics that underlies the transformer-based large language models is just vector math. It's linear algebra, right? And so it's just text token vector. There's some mathematical operation that occurs on it, and then it's vector token text. So there's some really good videos on YouTube, 3 Blue, 1 Brown. He's a mathematician, and he's got some excellent tutorials on understanding the mathematics of large language models. And they're not difficult. And so this is an example of the text to vector. And so I have a catalysis example. So if I type in, TiO2 catalyst synthesis, it gets tokenized to TiO2 catalyst synthesis, and then it gets embedded as vectors. And they're just numbers, just regular numerical vectors. And I have a little bit of detail about the matrix operation and the attention mechanism. So that attention mechanism fundamentally is just mathematical operations. So when you think about these things, they are incredibly advanced mathematical operations in, n-dimensional vector space where n is trillions. Okay, so transformer enhancement, it allowed these algorithms to be able to focus. I think a lot of us don't realize this, but human beings are sifting through all of the noise data that's hitting us every second of the day. So these algorithms needed to be able to do something similar, or they're overwhelmed by all of the data. And so the other thing was this allowed for fine tuning where we could use domain specific data and methodologies. And the one thing I want to really impress is, as scientists, these models, they're pre-trained on what I call standard English, right? Like things that you see online on Wikipedia. But a lot of what we use as our language is what I consider a subdialect. It is not standard English. It is very, very different. So think about that when you're using these models, when you're thinking about using an agent, you have to understand the limitations of what that pre-training language was. Because trust me, organic chemistry is its own language, okay? The great thing is that the pre-training part, I mean, basically everything on the internet that is openly available is used for the pre-training with, obviously illicit content not being in there and things like that. It allows for quick retrieval. So you type in something, you get an answer from a broad-based foundational model within seconds. And it's interdisciplinary. They are amazingly good at being able to connect the dots across different areas and see patterns. So what are they? Well, they're definitely sophisticated AI systems. They are meant to comprehend, generate, and manipulate human language. They are non-deterministic. So I know that you've been talking about machine learning as well. Machine learning is a standard mathematics that is considered deterministic. These are non-deterministic, and what that means is you can type in a task or type in a question every day for 5 days, and the words that it gives you may vary. The semantic content may not, but it depends on what the question is. If you ask what is the average temperature in Montana, Bozeman, Montana in June, it should give you the same answer. But the words it uses may be different, just like when you're speaking to a human, right? So some examples, it's OpenAI's models, the GPT versions, Anthropic has the Claude versions, there's DeepSeek, there's Mistral AI, which is a French open source company, Google Gemini, there's a lot of them, right? And they're constantly evolving. They're huge. They have billions of parameters. And when we say parameters, what we mean is billions of parameters that are changing as it goes through the pre-training. And I don't think that humans can get their mind around that, just thinking about the level of complexity, okay? And again, the training data is pretty much any open information, although there are some lawsuits where there's a question about whether they use information that they shouldn't, it's being litigated. Nonetheless, everything out there that is far beyond any of us could ever hope to ingest. So most of the models that we're using are pre-trained using standard English. There are specialized models now, thankfully, for other languages around the world. I mean, China has their own, India does. I don't know how many of their subdialects are being used for pre-training, but don't assume that a model is going to have been pre-trained on anything other than standard English, unless it was specifically built by people using that other language, right? And so the goal is they generate text. They do a lot more than that now, but that was fundamentally what it was, right? And they're great at being able to deal with complex information. They have novel ideas sometimes. Do not underestimate their abilities. I think that humans need to be careful of our hubris in thinking that we're the top of everything, right? The way these algorithms think, or the way they ingest the information, and then the way they present information, it's different. The process is different than the human cognitive process, right? And so realize that they may present things that we would be unable to come to because we have bounded cognitive processes, bounded in our physical architecture and our biochemistry and genetics and all of these things, okay? So they're great at summarizing, really, really good at coding now. Translation. So for example, PNNL has a model, it's Quen, and its pre-training was in Mandarin. That's great. So if you had a technical paper written in Mandarin, you would be able to use that model and you could translate it into English. It's also really good for doing collaboration. One, it helps with language barriers. And two, it helps connect the dots across disciplines. Now, fundamentally, you need to understand what the limitations are, and this goes to the ethics and the responsibility of the humans. So first of all, it's pattern recognition. So I want to be clear, when we say that it's not true comprehension, they don't think about something the way you might monitor your own thought process, okay? What they do is they're excellent at pattern recognition from very, very complex and large data sources. And they're much better at that typically than humans are. There is what I call a surface level output. In other words, it's good at recognizing these patterns, but the traditional broad-based foundational models, which is GPT-4, which is Claude Sonnet, 3.5, the non-reasoning models, they don't necessarily have the depth that you might be looking for. If you want technical depth, you're going to have to go to a reasoning model. And of course, they lack consciousness. These things are not aware. Okay, so more limitations, biases. So when I talk about training data bias, and that's in the pre-training, think about this. How much information was available on Bayesian type statistics versus another type of statistics? So if the preponderance of information that's openly available is mostly Bayesian, then that algorithm is going to be biased because that's mostly what it learned about, and it didn't learn about the other types of statistics. So you won't know necessarily if there is a skew or a preponderance of one type of information over another, but it is something that you need to be aware of, right? And that can lead to skewed perspectives. So accuracy, there's this great phrase, hallucination, right? These algorithms are really, really great at sounding authoritative, but they can be wrong, right? It can be plausible, but it can still be wrong. So that's why you, as the human, always have to verify and understand where a model may be weak, where it may not have a lot of information. And this is no different than if you're dealing with humans. So think about this. When you begin working with someone new, you might say, okay, yeah, I know that they're intelligent, but you don't have that relationship yet. So you have to build a relationship and get to know them. You need to do the same thing with your models so that you can have that intimate understanding of where, say, a specific OpenAI model might be weak, whereas an Anthropic model would really, really excel in that area. And know this, all of the models are different, okay? And they all have their own little algorithmic personalities. And it's up to you to understand that and to get to know them. So data cutoff, this was the other thing. So all of these models, at some point, they were pre-trained and then trained up to a certain date. The information that they would have available to them after that has not been where their parameters are going to be changed. They may have access to additional information if they have access to the internet. But fundamentally, don't assume that a model has access to the internet because it may not. And if you ask it, what is your training cutoff date? Sometimes they're not correct in what they tell you, but you can look it up. The other thing is, because of the superficial understanding, there can be some misinterpretation of complex concepts in your broad-based foundational models, as opposed to the reasoning models. So dependence. So this is something that there's been a lot of discussion about in the public sphere. These algorithms are going to make people lazy and stupid. Okay, well, I would argue that that could be true even before large language models. I mean, human beings have a choice to make. You can use your TI-86 or TI-89 graphing calculator or Mathematica or MATLAB and not really understand any of it. You can do that if you want, or you can actually understand the underlying mathematics and then use the tools to help you get the answer faster. This is the same thing, right? The over-reliance is you must be cognitively and intimately involved in the process. If you're not, you have abdicated responsibility. Can't do that, right? You need to provide human oversight, and you also need to understand that you have to balance what information you're getting from your algorithms and what you know, and maybe what your other human colleagues know, and even Mathematica. What is it telling you? So you have to use your judgment just like you do when you're getting information from humans. Every one of us, when we're sitting in meetings or lectures or seeing a presentation, we're gauging, do I believe this? Is it true? You may not even be aware that you're doing it, but you are. So privacy is another thing. obviously you don't want to put your social security number, or I would say don't put in your home address or anything like that. That's pretty simple. But the data management, so depending on which language model you're using, and whether you have a university account, whether it's a free account that may be on your phone, you have to know what's happening to the information that you provide these algorithms. It is incumbent upon you to understand that, and then to understand the consequences of that. Okay. So the free versions, sorry, I have a big fat cat. The free versions will not keep anything that you put in there private. They will indeed use them for updating their models. It doesn't happen overnight. There's a myth. Oh, I'm going to, I put my proposal in and I had it do some grammar checks, but now I'm worried because it's going to, ChatGPT is going to pop out my proposal to some person tomorrow morning. That's not true. That's not what happens. But they do use the information, and it gets mixed in with a lot of other information, unless you have a paid account where you know that that's not the case. And again, confidentiality, you have to be careful, and then compliance. So right now, there's a lot of litigation in terms of, what is appropriate, especially in the image generation. Can you put a journal article into any of these models? I will tell you, much to your horror, I'm sure, that almost every single academic publisher like Elsevier and Nature Springer, they prohibit downloading any of their articles from your institutional library services and then putting that into a language model. So that's what it says on their website. This is an ethical consideration. You have to check with the university or your business, whatever it is, and determine if that is the case, or if that particular institution has some kind of waiver, right? But there are all these things that are not necessarily obvious. So transparency. When you use these algorithms, you want to make sure that you are verbose in describing which models, why, and what they did. What was their role, in other words? And I think of my algorithms as my algorithmic colleagues and collaborators, right? And so I give them credit where credit's due, but I'm still accountable. 100%, I take full responsibility for anything that I put out there, even if 99% of it came from a variety of algorithms. Okay, the great thing is you can do literature reviews, hypothesis generation, data analysis, all of these things we can do much faster now because of these language models. I mean, as long as you're, really, really involved with the back and forth, and you have this intensive human in the loop and human oversight, you would be amazed at how well they can perform. However, I love this slide. So you need to know your LLM, and that's where you have to get to know them. So I have this great example. So I'm a physical chemist, and I did solid state NMR for 20 plus years. And so I go to an English professor. I know they're smart. And I'm like, hey, I want you to tell me what's going to happen if Schrodinger's cat is in a quantum superposition of listening to Beethoven and playing chess with Heisenberg's uncertainty principle. Okay, so the English professor is really smart. Do you think he's going to have a clue how to answer my question? Of course not. So the thing is, I did not understand who I was asking that question to, right? And so with the language models, you do need to understand exactly what those models were trained to do. What is their raison d'etre? If it's a broad-based foundational model, just like generic ChatGPT, it's going to kind of have like an undergrad degree in kind of general studies. You don't ask it about a quantum superposition because it's not going to know. And if you do, and it gives you a wrong answer, it's your fault. So that moves us to prompt engineering. So I don't like this phrase, but it's been around for a couple of years. So prompt engineering is basically knowing how to provide the information and or instructions to these algorithms so that it will respond in a way that allows you to get a useful and accurate answer, okay? Or whatever the task was, right? And this again is on the human. If you don't provide context, if you don't provide details, if you are very vague, that model is going to make assumptions that you may not know about. And that's really, really important for you to understand because it can derail you. So the first thing is you want to be precise in your language. What I've seen is that humans, we are not accustomed to being precise in our language, certainly not verbally, but you need to be precise. You need to understand the semantics of what you're either verbally telling the language model or what you're typing in. It doesn't have the sort of subtle, nuanced ability like humans to see your body language or to understand some context because it knew, the human knew something else, right? The only thing this language model is going to know is what you provided. So you have to think about that. What information would you have to give a person that does not know you to be an effective colleague and collaborator, right? If you do that, you will soar. It's like having jetpacks on your back. Trust me on this. It is the most wonderful thing. So here's just, clarity and specificity. So you can say explain sustainable energy and you're going to get a generic Wikipedia type answer. First of all, what kind of sustainable energy? What do you want me to explain? The economics of it, the technical aspects of it, the whatever it might be, right? You want to be specific and precise in your language. And then context and framing. So you have to set the context. So for example, when I was putting together this presentation, and I use something called Gamma to do it, and Gamma's wonderful. It made a lot of the images that are in these slides, and it does the formatting and everything. I put the text in, and then it does everything else. I made sure that it understood what my goals were for the presentation and who the audience was, because that matters. If I didn't provide that information, I would have gotten something out that was very, very different, and it would not have been appropriate, right? And so what you do is you iterate back and forth like you're having a conversation. This works really well. The other best practice I would say is at the end of whatever information you've provided these algorithms, you will always want to say, please let me know if you have any questions before we proceed. The broad-based foundational models, they need you to do that. And then they will ask you questions and you would be shocked at how astute they can be. The reasoning models, on the other hand, typically you don't need to say, let me know if you have questions, because they will come back with questions on their own because they are different. Algorithmically, they are very, very different than the broad-based foundational models. But it's still good practice always to say, please let me know if you have any questions before we proceed. Okay, so LLMs in research with the human in the loop are amazing. It's it increases your productivity, but what I've found is that there is a psychological effect to this. And so I've always been kind of an overachiever, and being a scientist can be rough because we can have a Darwinian culture in that you don't want to admit that you don't know something, right? None of us want to admit that. We might feel ashamed, especially if it's something that we think we should know, even if we shouldn't. And so what I found is that when I'm faced with something that is difficult and I'm worried, 2.5 years ago, I would have been worried, am I going to be able to do this? Is it going to be good enough? These tools give me ease in my mind because I know that I can learn anything, literally. Well, maybe except for string theory. That blows my mind. But anything else, I can learn and I can figure it out, and I can do it relatively quickly. And that is amazingly intellectually freeing. Okay, so AI-ready data. What is it? How do you get it? And this is actually a huge problem, both for the companies and for us. First thing is, and this is true for machine learning, basically, if the data is not machine readable, it's not useful for the machines. There's nothing you can do, right? So the first thing is you have to have your data structured in a way that allows it to be not just machine readable, but so that it has a logical flow through the data. And you have to have metadata. So metadata to me is just context. In other words, if I run an experiment on a battery material, the NMR experiment has the instrument metadata, what temperature did I run it at, what perturbation did I use? But how about what was the sample? What happened to the sample? What are we analyzing for? What are we interested in? All of that is something that the human has to append to that raw data set. And a lot of us, we don't do that. So the first thing is, when we do it, then there's discoverability. So you can search on metadata. Second thing is integration. So you can integrate different data types. So it could be mass spec, could be NMR, could be electron microscopy, right? Without the metadata, you don't have those common hooks to be able to connect the data. And it also is super efficient. So I learned with running solid state NMR, there was a little text box. And so what I did is I had a little format where I put the same information into every single experiment. You know why? Because if I didn't 6 months later, when I pulled up that data, I wasn't going to remember what on earth, exactly what sample it was or why I was looking at it. So it really helped my efficiency. So you want to optimize your data so you're going to have it structured. You want to make sure it's clean. In other words, if you've got some, CSV file that's ragged and some columns are missing things, but not all of them are, this is not good data. You got to clean it up, and you got to have the contextual metadata. So the large language models, they really like JSON format, they like ASCII, and they like Markdown. Those are their favorites. I try to turn everything into JSON if it's data. If it's just text, I always use Markdown. So the language models, their pre-training was actually in Markdown. So they are intimately familiar with it and they like it. It's highly structured text. It's super easy. You can buy a $30 extension to Word. It's called Writage. It's $30 and it will move back and forth between regular Word formatting and Markdown. High quality and clean. You need to have it. I put comprehensive metadata, but we'll get to that in a second. And all of this allows for interoperability. So the first thing is the data cleaning and pre-processing. So I do a lot of Python scripts to clean things up. You could use probably maybe you could use R or something, but you do need to get in the habit of cleaning up your data, or when you generate it, to make sure it's clean, right? And then you're going to want to immediately have it structured in a machine readable format. And a best practice, get in the habit of putting in the metadata and the context and associating it with the raw and the process data. So for some of us, there are what's called ontologies, and I'm not going to get into the details of that, but basically, if in NMR, I'm talking about a T1 measurement, that needs to be defined. And if there is an ontology, which is just a structured dictionary of terms, essentially, then I need to make sure that I'm using that definition and not something else, okay? You're going to want to document everything you do. Just like the software developers, they have the README files, they have all the documents. Scientists need to get in the habit of doing that as well, especially when you're using these algorithms. You're going to want to document it. If nothing else, it could be an intellectual property issue. So one of the things that you can do is you can actually leverage using large language models to help you structure your data and to identify what I'll call the minimum metadata. So I use the large language models. I basically give them sort of machine readable raw data, right? It could just be a CSV file and it could be a mess. And I basically go back and forth and say, okay, what do we need to do to clean this data set so that it's highly machine readable, right? And you'd be surprised. They will come back and tell you exactly what you need to do as long as they can parse the information you're giving it. So some files, they're proprietary binaries or something. Clearly, the language models are not going to be able to read that. It has to be in something where it can ingest. But usually you can export the data from a proprietary binary into an ASCII file or something like that. So I think about metadata is, what is the minimum metadata necessary for any experiment type? And it could be a project type or whatever. What do you need so that someone else could open the data set and actually have a clue what and why you did what you did, okay? And so the language models are actually really, really good at identifying this. And it's funny because in software development, they have something called minimum viable product, MVP. So you can think about minimum metadata as like an MVP. What's the bare minimum so that it's not a burden on us, right? It's super efficient, and we can have standardization. So these are definitely some challenges. We have a diverse data type. So you've got NMR, you've got mass spec. They're completely different. What metadata do you need for each one? Then it's researcher dependent. So most of the metadata that's critical is in our heads. It might be in our lab notebook if we're lucky, or on Post-it notes if we're unlucky, right? And consistency and standardization, there are not ontologies and schemas for a lot of the fields that we work in. They're not agreed on. And so how do we deal with that? If there's no agreed upon definition of some parameter, then I would argue make your definition and simply put that in your documentation. So what I do is I allow the large language models to basically sort of move through the data and tell me what they think about it and what information they would need. So what's the minimum metadata they need to be able to understand and analyze those data? And they will tell you that, right? And so this is what I do. I have the data collection. I use my Python scripts if I have to clean up the data. I provide that data to multiple large language models. So you're going to want to use multiple algorithms because they're all different. They all have different strengths and weaknesses. And then you can see where there's consensus and where there's variation, right? So we get this, we make up definitions if they don't already exist, and we put that in the documentation. We do this with careful prompt engineering where we use precision in language. And I have here basically knowledge graph integration. We're not going to talk about this, but ultimately, if you go through this, you can generate knowledge graphs, and they can be amazing windows into the connections that you wouldn't otherwise see. So this is just the same thing. Get your data, clean it up, and organize it as a CSV, a JSON, a Markdown, but it must be structured, right? Then we identify essential metadata. We can create domain-specific standards. Again, if the standards don't exist, then create it and put it in your documentation. Don't wait for someone else to do that, because in my experience, they don't. I've been working in what's called cyber infrastructure, which is now sort of the data and machine readable data, since 2001, and not much has moved forward since then. And this is just, it's a little workflow. Basically, you have to use precision in language when you're interacting with these large language models to be able to understand what metadata you need for any given data set, right? And you iterate and you go round and round like you're having a discussion, right? And so a simple prompt would just be extract essential metadata from the following experimental data and structure it as RDF triples. Okay, so that is really straightforward, and it's bare minimum. There's no context, there's nothing. The reason I do this is to find out what these algorithms understand from the data in the absence of additional context. Because it's like working with a human. You want to figure out what they know without you having to tell them. So I do the same thing with these algorithms. So the LLM processes it. What we're looking for is automated validation. So all of these workflows, and we're talking about agents as well, there is an initial very, very intensive back and forth between the human and these algorithms to validate them. So you don't just build it and not test it to make sure it's validated. It is a very cognitively intensive process. So you have to use data that you know really well. And you have to basically stress test the model to see what it comes up with. Once you've done this with a representative sampling of the types of data you're going to be using, and you have ascertained that the information it's providing you is in fact accurate, then you expand on that representative data sampling to larger data sets. But you can never, ever, ever do that without going through a full validation process. And in many cases, you will be the one that defines exactly what that validation process is, because the computer scientists don't do it for us in domain science. Their validation processes in general don't work well for our workflows. Okay, so right on the nose. So here is an acknowledgement slide. And I want you to understand that I do this with everything. So I acknowledge the assistant of OpenAI models and Anthropic's models and the development. They contributed to content development. I mean, I detail everything. And I'm specifically Quad 3.5 Sonnet was really, really good in this. And basically, you can go through and you can read this. I talk about using gamma, and they're just like my colleagues, and no one can ever come back to me and say that I wasn't transparent about the tools I use or how I use them, or the fact that I am ultimately responsible for everything in here. If something's incorrect, it's on me. It's not on the language models. Now, I want to make the connection to agents, right? Because agents are more complex than just going into a web interface or using an API with these models. If you don't have the ability to go through and iterate and to think about validation, right? You might want to pause before you think about pulling an agent workflow, say off of GitHub or Hugging Face. How are you going to validate that? How are you even going to think about it? And they're more complex workflows. And so I put this presentation together trying to get everybody to understand the foundations of what you need to understand and the way you're going to interact with these algorithms before you move into anything that's even remotely like an agent, where it's much more complex and much more a black box, and you really don't know what it's doing, right? Anyways, so thank you for your attention. And I am very, very happy to take questions on pretty much anything.
Thank you, Nancy. That was fascinating. Do we have any initial questions in the room? Otherwise, we can move to online because we have quite a few online.
Abby, we have one right here.
Oh.
Hi, thanks for your insightful presentation. So how do you handle missing and zero values in a dataset, and how do you make them ready for feeding them into AI or in machine learning models?
So wait, what was the first part? How do I deal with?
Missing values and zero values.
Yeah, right. That's part of the data cleaning process. So the reality is you have to get rid of it. Or I would say in machine learning, you could probably structure your algorithm to ignore it. But with these language models, it gets a bit trickier. And so really, I go through and I delete all of that, even if it means I'm deleting some of the data that I collected, right? And that's another thing you have to be very, very cognizant of, right? If you have to remove data from the data set because it's missing things, right? You have to try to understand, is that going to skew the data set in some way, right? Or bias it in some way?
Yeah, just as a follow-up to your answer. So let's assume the missing values and zero values account for variability in the dataset. So if the dataset becomes skewed, then the results will be skewed, right?
Yes.
So what should be the ideal strategy to handle them?
I don't know.
Does it depend? Does it depend on dataset or vary
It
from?
does. So here's the truth. When you say that those values could represent variability in the data set, I would come back and say, tell me what the data is, tell me what information the data is providing, and I would basically go through multiple iterations to try to understand the consequences of removing those pieces or of putting dummy values there. That's another thing that you could do, right? So again, this is part of the benchmarking and validation. I don't know what the best method is. We have to sort it out.
Thank you so much.
Hi, I don't think it's a question. It's just like point out the biasness. As you showed, most of the pictures did show like intelligent being as bipedal humanoid structure. Do you think we have, all the data we have has trained our LLMs in a way that like, oh, intelligent beings are supposed to be humanoid? bipedal and
Yes,
not just like dog or dolphin?
I absolutely believe that. And I think it's a terrible bias on humans' parts because clearly we're the top of the heap. And anything that's intelligent as us or more intelligent is going to be similar to us, right? And that's nonsense. I mean, it's actually a fascinating philosophical topic.
Let's take a few online questions. There's one, is there a pre-established basis of knowledge that these systems are working from that causes them to break up chemical formulas into multiple vectors rather than capturing titanium dioxide, TiO2, as a single word?
So that's actually an interesting question. So what I would say is it is purely a matrix mathematical operation. In other words, the text that we put in, it is not recognized in text form. So I can type in TiO2. That language model is never going to be presented with the letter T, the letter I, the letter O, and the number 2. It will only be presented with a vector that represents that. And so I would say, I don't know exactly how to answer your question, except that it is just a mathematical operation and there's nothing else. It has nothing to do with a chemical formula versus the word serendipity. It just breaks it up based on the size and being able to vectorize it.
Great, thank you. Another question from online, unless there are any more in person. So do you think it is better to ask AI questions in English rather than in another language? Or does its training make no difference nowadays?
Oh no, and it's really the pre-training that's critical, right? So there's pre-training and then there's training and training with, reinforcement learning with human feedback. There's all these things, right? And so what I would say is it absolutely matters. So the majority of models were pre-trained on English language because English language information dominates the web. That's just reality. It does. Okay. Now, a lot of vendors, and one of them is, starts with a C. God, I'm glitching out. This is called the tip of the tongue moment. They are developing models where the pre-training is in other languages. So absolutely, it matters. And you that's part of your responsibility in getting to know the model and understanding it.
That makes sense. From your experience, is that information about the way the model was pre-trained or trained, is that easy to find?
Yeah. I mean, well, easy is subjective, right? So every commercial entity and most of the open source entities, they have documentation. I mean, you can go to, so I use Perplexity AI to replace Google. I don't use Google anymore because they fed me a passport link and it was a scam site and they refused to take it down and I got mad about it. Anyways, I've been using Perplexity and it's really nice because you can go ask it questions like that and it gives you a superscript number that you can click on and it will take you to the original source information so that you can verify it. So I always go to Perplexity to ask things like that. And then I click on it and I go to the vendor's documentation. So it is available, yes.
Great, thank you. All right, we'll keep going through the online questions. Are there models that are able to answer questions based on your body language or other characteristics? And if so, how complicated are these models? And we had a few follow-up questions to that question, but you can start there.
I can tell you that the broad-based foundational models and the reasoning models, which are 99% of them, at least in the public sphere, they do not have the ability to have your camera turned on and for that streaming video to be ingested and parsed. At some point, they will. They don't right now. I would say the closest thing would be from verbal transcript. So like Notebook or Notebook LLM does it, but all of the cloud vendors, Microsoft Azure, Google, Vertex AI, and AWS, you can upload a verbal transcript, let's say of, some podcast or something, right? And they can infer emotion from tone. That's the closest we can get right now. But we are headed there. And it's a little dystopian if you think about it.
Yeah, that's true. I would agree with that. So if there aren't any current models that would be able to answer questions based on body language and stuff like that yet, do you imagine that when they are available, they might be able to handle variations in nonverbal communication, either due to cultural differences or autism?
Yes.
What are your thoughts?
I absolutely think so. I mean, 90% of human communication is through body language, right? I don't know if you all realize that. And which is one of the reasons why during COVID, when everybody was under lockdown, it was really stressful. It was really difficult because humans are not built to interact through screens. Like you can see me, I'm moving my hands around and stuff. But if I was there in person, you'd see me, my whole body, because I'd be walking around on stage, and your sense of me would be different than through a screen. And so what I'll say is, you actually can use the models to answer questions about body language if you can describe the body language in text or voice. It's just, it doesn't have the ability to get a streaming feed that is visual and to be able to parse that. So you absolutely can. I would say that in particular, the Claude models from Anthropic have a very high EQ, an emotional quotient. They are very, very astute about human behavior in ways that I found surprising about 18 months ago, and they've only gotten better. In terms of the cultural differences, you can do that now if you can convey through verbal, because they all have voice now, or through text. Again, it just can't do the streaming. I think that it could be very helpful because as I see it, one of the biggest problems that humans have is we don't all speak one language. I don't think we should, but what I'm saying is that there are nuances and subtleties to language, right? That are different based on which language or which subdialect. And it's the same thing in science. When I'm talking to a high energy physicist and we're using words, we may not realize that those words have very, very different connotations within our little domain and subdomain. And therefore, we're not even talking the same way and we don't realize it. So yeah, these language models absolutely can help us translate through those barriers. And that would include, unfortunately, the barriers that non-neurotypical people have to face in a world that's not set up for them.
Thank you. That was very insightful. We can move on to the next online question. Are there any AI platforms that can automatically structure data for ML?
Well, I guess the first thing it would be, it depends on what kind of data. I mean, so the answer I guarantee you is yes. You can go to, GitHub or Hugging Face and find things. It completely depends on if somebody spent some time building the code to do it. But sure.
Sure. Okay, another question. So what types of data analysis do you do with LLMs? Does it include figures generation for publication, or are there examples of models to use?
So I don't do hardcore data analysis of my scientific data, like my NMR plots. I would never use these algorithms right now to tell me, what the peaks mean. I just wouldn't, because I don't need to. It's intuitive now. What I do use them for, I can create custom plots And when I say custom plots, so in the presentation, I had mermaid plots. They were the little block diagrams going from text to tokens to vectors. So all of that, I use large language models to generate. And in particular, the Anthropic Claude models are really, really amazingly good at this. And so what they do is they will actually just generate the mermaid code, or they'll generate SVG, raw SVG code, which is what Acrobat Illustrator uses, okay? It can also do React, and it will have the code, and it will also show you the image. So I actually use the code itself. I take it from the large language model, and then I work it up, you know, either in another platform that does mermaid diagrams, or I just use the Google or Safari web interfaces for the SVG, right? And you can create full custom flowcharts and things like that. I would never use them for like, here's my NMR plot, I want you to spruce it up. It's basically not built to do that. So I've never tried it, nor had I ever had a desire to do that. The other thing you have to realize is that most publications prohibit you from having any figures in your technical papers that were generated by artificial intelligence. And unfortunately, that's true even for some of the table of contents, kind of cartoony ones that are more like, you know, they're marketing graphics. And that's too bad, because there are some phenomenal image generators like Midjourney. So my little asset bug behind me, this is Midjourney, and I do this for fun. I don't do this for any technical publications or anything. I do it because if you want to be artistic and you were never able to be artistic, which is me, I can use language now to be artistic, and I'm really good with language. And so now it's this creative outlet that I love.
Thank you for mentioning that. I love your background so much. So following up on that, it makes sense to me that we wouldn't want to use AI generated images, but what about AI generated code that creates the images for us? Because in that way, we could at least check what was done to create the image.
And that's exactly what I use Claude for. So I get the code, right? It shows me the image. I then, you know, I copy the code, I put it in my own little platform, whatever that might be. It's, you know, something in Python on the command line that I usually do. And I actually go in and I tweak the lines of code to get exactly what I want. And I think that's what we should be doing, right? Don't just, you know, do a screenshot or try to download the image as a PNG or something. You want to make sure you understand what's going on under the hood. And plus, it's really, really fun when you realize you can literally create any kind of custom chart, or, I mean, there are limitations, right? But a lot of the things that I do are flowcharts and workflow processes. And now I don't have any limits on how I can create that and what it's going to look like.
Wonderful. Thank you. I think we have time for maybe one more question. So I'll take one from the chat. The size of a data set used for AI is critical, but oftentimes the size is limited due to the difficulty in certain experimental analyses. What would be your suggestion to process a relatively small data set using AI?
So first, you're talking about being in a sparse data regime. So there's two different things here. One, it's just processing the data. And two, it's being in the sparse data regime, but really needing to have a larger data set for machine learning algorithms, right? And so the sort of processing, whatever that entails, the sparse data doesn't matter, but it's getting enough of it so that you can train a machine learning algorithm. And so there's a lot of work going into what's called synthetic data. And there's a lot of debate about this in the community, right? And it's very polarizing. So what I'll say is that there are research efforts undergoing right now to try to determine if the large language models and the reasoning models can generate synthetic data that isn't skewed or biased in any way, and that reasonably would fill in to provide a representative sampling for sparse data regimes so that that could then be used in machine learning algorithms. And it is really an open question right now.
I see. Thank you for answering that. That's all the time we have, but thank you, Nancy, for your great presentation and taking the time to answer all of our questions. Your presentation was very engaging and fascinating. Thank you so much.